Hi, welcome to Detours Understanding Acquired Brain Injury. And today I'm going to be talking about toxic and chemical um, encephalopathy. Now, the reason I mention chemical is because a lot of people misuse uh, the term toxin, toxic. Toxins are produced by living organisms, okay? Chemical is more generalized. While toxin is used generically and even like way outside of its proper application, like talking about toxic people or stuff like that. No. Toxin applies to something, usually either a defense by a living organism, or a part of the metabolic process or whatever else. Toxin is not applicable to, for example, synthetic products that are chemical. So a chemical encephalopathy, medications would be a chemical encephalopathy and would be considered a poisoning. But generically, you'll hear the word toxic used, so toxic encephalopathy, but really it is a chemical encephalopathy because it is made synthetically, medications. Now, alcohol, that would definitely be a toxic type of encephalopathy if you have brain damage due to alcohol abuse or certain drugs. They're kind of semi-synthetic, many of them, like crack or cocaine or other things like that are sort of because an organism's byproduct, a plant, is involved in the production of psychoactive compounds that do damage. But if it is something completely synthetic in the laboratory, it's a poison. So it's a chemical encephalopathy, and it is important to know the difference. A venom is indeed a toxin, and it is envenomation, but it is a toxic product. If it is a jellyfish, or if it's a snake, or and if it's a poisoning, if you ingest it, and it's a plant product, or if it's like the poison arrow frogs or something like that. So this topic is kind of complicated, but to make things simple, I will call it toxic encephalopathy because that's kind of like what's used generally, but there is a difference, and it is important to make it clear that toxic and chemical encephalopathy, there's definitely a difference. So if it is made by people through a chemical process in the laboratory by putting together the precursors to make this product, and nothing living is involved in the product that causes harm, and I'm not talking about mixing it by people to nitpick it. No, I mean if it is made synthetically completely, then it is a poison. Sure, you can consider things like strychnine and whatever else poisons, but really it's a toxin if an animal or plant or other living thing produces it as part of its defense, or bacteria or other living things make it as part of their defense or way to keep away predators or for some other purpose. Other than that, it is a poison. All right, done with that. So, toxic encephalopathy, which we will use for both sides of this from now on. All right, so toxic encephalopathy, what is it? Well, there are different ways of looking at this, but anytime the brain is injured by being exposed to an outside agent, and this can happen in industrial situations or corporate settings where it's part of your job to do anything from like mixing paint or making plastics, which is another source of toxic encephalopathy, or making medications, or developing any other kind of product, metals, handling specific types of metals, the so-called heavy metals, which has to do with their atomic number. We've talked about that in the past, but things like mercury, a specific type of mercury. Not a lot of people will jump on the anti-vaccine bandwagon, but the truth is it's only a specific few variants of mercury and not the types found in the vaccines. This is a special type of mercury often used for making felt, or hence Mad Hatter, by the way, or used in making developer for film. It was even used in some forms of rocket ignition sources, or used in early forms of primer for guns and shells. I'm not sure if it still is for shells, maybe, I'm not sure. And used for other, like, heat and ignition sources. It's used in laboratories a lot. There have been and still are occasionally researchers and physicians and, who are accidentally exposed to these kinds of inorganic types of, well, actually some variants of organic as well. We'll talk about that later when we get into metal-based poisoning. Lead, arsenic. Arsenic is a heavy type of metal, which in fact is actually used in the respiratory process by some life forms. So what was deadly to us because of the way it acts on the brain and the respiratory system, circulatory system, is necessary for life for some organisms. Same thing with cyanide. Again, necessary for some living creatures for them to survive. And even we use a small amount of it in the cellular process, but we're talking about like nanograms of it. And it can be very disruptive if it's outside of a tiny, tiny amount. So we use for it. And I mean, extremely small amounts. So, yeah. So heavy metal poisoning at work. Volatile organic compounds. These are chemical products that vaporize at a low temperature and become airborne. So VOCs, we will talk about that. Also, well, there are tons of these, lots of these paints and like toluene and a lot of like pigment-based products and dyes and other things like that, which are very, very neurotoxic. And neurotoxic, referring to these, are technically neurochemical, but again, it's that toxic thing. They will destroy neurons directly, and they will cause damage in other ways. So volatile organic compounds, cleaning agents, again, used in, obviously in cleaning. That's like the bleaches and the ammonia, also like any kind of the germicidal stuff. Obviously that's destructive to cells in general. And so that can be harmful to DNA, that can disrupt cellular functioning at the metabolic level, as well as the way it encodes proteins, things like that. And it obviously kills cells. So those are just, well, some of the things people are exposed to at work. So what else? Then there's risk of exposure outside of work recreationally. And I'm talking about alcohol, illegal drugs. These are chemical. These are both poisonings as well as toxins. Alcohol, as I said, PCP, neurotoxic. Marijuana is like, it alters development and growth of neurons depending on your age. Direct toxicity, direct neurotoxicity, uncertain. But it certainly can alter the way neurons function. But damage to the heart, lungs, hypoxia. So, heated smoke, damage there. So certain things that need to still be kept in mind. But the number one problem, the number one most dangerous, as far as the illegal substances, is it's legal, but it's alcohol. Legal substances is alcohol, and illegal would be actually GHB. As far as neurotoxic and MDMA, it's right there in the same bucket, and they both do it the same way. And that would be hypoxic events, lack of oxygen. Alcohol kills neurons directly, as well as you seeing hypoxic events and things like that, which we talked about in hypoxic ischemic encephalopathy. We'll be getting to neuropathology more in depth when we focus on specifics. But yeah. So also, there's home exposure through accidental poisonings around the house, kids or older folks who overdose on medication, prescribed medication. There are a lot of different medications where that can cause neurotoxicity. And it's a question of misdosing, forgetting, taking too many, taking wrong drugs in combination, prescribed medication, chemo drugs. Many of those destroy neurons. Many of those cause other effects. Anticonvulsants, if the medications are misdosed. Direct neurotoxicity that's a complicated one. There's not a whole lot of research showing which ones are outright neurotoxic, which ones cause other kinds of injury, or which cause interference with neuroplasticity, things like that. It's not as clearly spelled out with the research, but we do know that too high a dose, suicide attempts, moving the decimal point wrong on a prescription, or pharmacy error, whatever. There are certain agents that really can cause severe brain injury. Interactions. So yeah, medications are a source of acquired brain injury, toxic. There's also cleaning agents at home. Sprays for dusting, and whoever still does dusting, I'm not sure, but I know there are plenty of, and those who have, as well as, to clean the toilet, those kind of chemicals that are used for cleaning, things like that. Stuff we use for cooking. Coatings on pans and other things we thought were harmless turn out not to be so. Pesticides, insecticides, other agents we use outside, or that your neighbor, if they're maybe a farmer or whatever, sprays on their field. Many of these have toxic effects. Things that your township may use when they spray along the road to keep the dust down. A lot of dangerous substances there. Again, they use things combined with metals. We're around chemicals all the time, from your car, from the exhaust pipe, benzene, that also, diesel exhaust, diesel fumes, gasoline fumes, volatile organic compounds. We know that too much exposure can cause brain injury also. Docs, nurses who are exposed to anesthetic fumes, who over time, it's not just receiving, not being put out for surgery, that's a problem over, just a surgery or two or a few surgeries, but an anesthesiologist or a nurse anesthetist who gives it day after day after day to patient after patient, that stuff is, guess what? It's neurotoxic. So, and those who handle these medications, the pharmacists, the physicians, and other people who are handling it, plus all the plastics. There are different routes of absorption. You can obviously inhale different types of toxins. You can absorb them through your skin. A lot of people don't think about this, but yeah, your skin has pores and is well, in certain areas, has good circulation. In other areas, not so good, but there are a lot of poisons that you can draw in through your body, through your skin. So inhale through your skin. Ingestion. Injection, we mentioned about that, both intentional, whether it is a legal drug or illegal, and obviously eating it. It can go through other mucous membranes too. eyes, ears, reproductive organs, anus. Yes. Anywhere that's well circulated, anywhere that's got circulation, it can be absorbed. And things you might not think about. What's in your water should be tested. Some of the bacterial cases of brain injury coming through neti pots that are not properly cleaned through the nose. So it's important to know your environment. This isn't to make anyone paranoid, but is to make you aware that it can come in a variety of different ways and stuff you may... It's important to understand. And it is important to be careful. These chemicals are necessary. These products we use are necessary, but they need to be treated with respect. All right, now how do they cause brain injury? There are a couple different ways. Probably one of the most common ways most of these cause is through hypoxic ischemic encephalopathy. They cause damage to the brain by interfering with circulation or by reducing the amount of oxygen that can be absorbed into the neurons, either by stopping the heart outright or by reducing the amount of oxygen that gets delivered to neurons. So I have a video on hypoxic ischemic encephalopathy. So that is a significant way, many different and I talked about asphyxia or chemical asphyxia, which is where it binds the hemoglobin on the red blood cells, and where, for example, carbon monoxide is an inhaled chemical or neurotoxin, depending on where it's coming from, and that can cause hypoxic ischemic encephalopathy. But it also causes toxic encephalopathy. Cyanide is another. Cyanide is a chemical asphyxiant. How? It binds the cell's ability to transfer oxygen and carbon dioxide. So it interferes with cellular respiration. It interferes with respiration. Pardon me. Yeah, it interferes with cellular respiration. I didn't mean your red blood cell, but I'm talking about cellular respiration. Sorry, cellular respiration. I did not mean red blood cells. What I'm trying to say is cellular respiration. The ability of the cell to exchange oxygen and carbon dioxide. That's what I'm trying to say. Sorry about that. Cellular respiration. But it's the same idea in that being able to exchange oxygen and carbon dioxide. So it cannot produce energy, ATP, on the mitochondrial level. With apologies. So it's still chemical asphyxiation. And that is how other toxins like that work, to interfere with that. After hypoxic ischemic encephalopathy, another way that toxins and chemicals interfere is that they will have pharmacological effects. Now, this is mainly with medications, drugs, but they will lock onto receptors on the pre or postsynaptic end of neurons. And they will trigger an extreme response or interfere with the response of the neuron doing what it's supposed to do. And some, like many venoms, are bind permanently irreversibly to these receptors and cause the neurons not to be functional anymore. Some neurons can eventually, they'll consume that receptor and in a couple weeks will generate a new one. Others are unable to do so, depending on what kind of neurons are bound, what receptors are bound, what their function is, whether they bind to a primary, secondary. In any case, even if they're able to get rid of those receptors, you'd have to be on a vent for a very long time, because many of these bind acetylcholine receptors, which help with regulation of breathing and things like that. And so it's how that works. Antivenom binds those proteins. But that's how. But other medications and drugs will do the same thing. They will trigger an intense response in the brain. They may even set off that cellular destruction cascade we talked about in head injury and hypoxic ischemic encephalopathy, which would add to your problems when dealing with medications and trigger cellular apoptosis, cell destruction, cell death from the pharmacological effects. So some act like they're medications, and what's interesting is some also act like hormones. You will find this for plastics, for example, precursors for making plastics. And so some will act like estrogen, progesterone, testosterone, and will affect sexual development or may cause certain cancers, things like that, and brain cancers and things, inhalation exposure to certain precursor compounds. It's believed to be that this effect is one of those effects that causes, cancer that's seen in a lot of anesthesiologists and docs who work around like closed, unventilated spaces with certain volatile organic compounds like anesthetics. But this is also one of the ways that like paints and dyes and other things can cause brain injuries through pharmacological effects. Inflammation, we all know that one. Neuroinflammation. We see that also with VOCs and some other, most of them will cause this to some degree. This causes, we were dealing with a breakdown of the blood-brain barrier. We talked about this with traumatic brain injury and with hypoxic ischemic encephalopathy. So if the blood-brain barrier starts to break down, you also get the incursion of phagocytes and other immune cells that will attack injured neurons. You don't want that because they're supposed to heal, not be destroyed, but that's what happens. So with, again, exposure to these compounds, these various toxins, you get destruction of the brain from inflammatory factors, which normally would be helpful. And you get cytokines and you get tumor necrosis factor and things like that in there. You don't want that. But with the breakdown of blood-brain barrier, that barrier between the brain, which is a series, basically it's a web, a network of capillaries whose job it is to let food and nutrients in and let helpful markers, hormones and other markers in, and let waste out, but keep out products of the body and viruses and bacteria and chemicals and other things, keep them out, and even things that are helpful in the rest of the body but just don't belong in the brain, which is much more sensitive and delicate. But if it breaks them down, then you get all that kind of stuff in there that you don't want in the first place. And then you also get the cytokines and other triggers of inflammatory responses in the brain. So you get swelling, edema, all kinds of other fun things like that too. No thank you. You get mast cell activation and not good. So, all right, so pharmacological effects. That's also a really big one that often gets missed, but due to exposure to these kind of chemicals. And so you, as I said, so you've got then that fourth component. So these are the primary causes of the brain damage that comes from exposure to toxins. I mean, now some of them will just outright destroy neurons too, depending on what they are, how they're put together. They may cause, just direct cell death, apoptosis and necrosis of neurons, depending on how they function. They interfere with cellular metabolism itself. They just are, it functions a lot like traumatic brain injury or hypoxic ischemic, but lack of oxygen is a significant one, as well as pharmacological effects, inflammation, and direct cellular necrosis, destruction of the cells. So these are the ways in which chemicals or toxins destroy neurons. Should sound familiar because these patterns are very similar. Triggering off that self-destruct cascade. Same thing, chemically inducing. And one of the other things is that each of these classes, and within each class, specific neural response is different, like how it does this. But these are the general things you should expect. And there are novel responses within each group. So we would have to look at it differently as we go through. And we will be talking about the major classes and like where you might be exposed to these things at home versus through occupational exposure and exposure in unusual situations, or maybe outside, maybe looking at venoms and things like that and how they work, how they cause acquired brain injury. And something else I want to touch on, the other CTE. We hear about chronic traumatic encephalopathy, but there's chronic toxic encephalopathy. This is important also. Chronic toxic encephalopathy deals with a lot of work cases where over a long period of time, people who work with substances that normally would be below what the National Institute of Occupational Safety and Health says, oh, this is okay. NIOSH says, yeah, this is all right. But if you're breathing certain things or you're touching and handling certain things over years, or a very, very high dose exposure over a short term, can cause chronic effects for things that you might go, well, wait a minute, this shouldn't cause a problem. Well, if you get a strong enough dose, or if you get a long-term dose, it can cause specific problems. And so it's important to understand, again, what you're working with. And that it's required that your employer have what are called MSDS, Material Safety Data Sheets. And many of them now put these on computers. But you still need to be able to access and look at what you're working with, so you know what things present a hazard to you. There are physicians that specialize and nurses that specialize in occupational health, and this is workplace dangers and hazards, and to the treatment of occupational medicine, occupational diseases. These docs can assist if you have an exposure, an accidental exposure to something that is dangerous in your line of work. A lot of them do research, or they will assist with, say, poison control or something like that. And there's a separate type of doc. They're a toxicologist, a medical toxicologist, and there are nursing toxicologists and all this other stuff. But they are more specific to chemicals. But you also might want to look for them if you're having some symptoms. All right, so what kind of symptoms generally are associated with? First of all, there is a list that was developed related to chronic toxic encephalopathy. There's acute exposure. There is chronic mild encephalopathy. And then you're looking within that one, within the mild, there's neurobehavioral effects and neurocognitive effects, or neuropsychological. So neuropsychiatric, neuropsychological effects, and chronic major effects. We'll put that up here, the specific list. So neuropsychiatric effects, if you have chronic toxic encephalopathy to a milder degree, you may just have some neuropsychiatric effects. But these can be some of the most disabling. I've never liked labeling things like mild or moderate or severe or whatever, because it suggests it's not as bad. Some of the neuropsychiatric effects are way more disabling. Mood changes, anxiety, panic attacks, depression, paranoia, irritability and anger, apathy, adynamia, should sound familiar. There's, these are the kind of impulsiveness, kind of personality regression sometimes. Again, it depends on to what you're exposed. Changes in personality. Neurocognitive, short-term memory loss, Problems with learning new information, um, problems with organizing, planning, the dysexecutive stuff that we talk about all the time, reduction in intelligence, um, problems with planning, abstract thinking, changing and adjusting to new information, stopping and starting behaviors, activities of daily living. As far as like sensory and the more severe stuff, problems with your vision, hearing. One of the interesting symptoms for volatile organic compounds is changes in color vision, problems with discerning colors with the fine differentiation within colors, or vibration sensation in the fingers, tremors, akathisia, sensation, the ability to sense, temperature regulation, GI problems, and then it starts to spread into like general bodily, balance and nausea, vomiting, problems with, throughout the body, kidney and liver problems, and heart, respiratory. It just spirals from there. So eventually, if it's severe enough, seizures, coma, death. This is why expertise in this area, which unfortunately is not very well researched, because a lot of people are involved in litigation, especially against employers, and separating people who are motivated to not perform as well because they have external motivations or have issues with anxiety or whatever else, and don't have a bad motive, but certainly are motivated by anxiety or whatever else. It's hard to tell. So what do you do? And so researching this is really difficult, and finding those who are no longer being involved in suits or are able enough to participate is a challenge also, especially for forensic neuropsychologists, which is a separate area of research. Researchers that they have been finding it somewhat difficult. Denmark did a bunch of studies. The Nordic countries in general, amongst their painters and spray painters and things like that, to see what they could figure out for this. Same thing with pharmaceuticals and other things like that, trying to figure out what effects are, and even large-scale studies will miss out on, if it's a new medication or something that's only been on the market for a little while, figuring out, what might be the effects of something decades down the line, or even a couple years, till many people are taking it. And each person's genes are different, their chemistry is different, and so it's a bit of a challenge. And if it helps a lot of people and hurts a few, weighing, what at what cost? That's a big neuroethics question. All right, so what do we do? Don't know. We can't get rid of all the chemicals. We need many of them. We need them to be able to grow enough food for all the people there are on the planet. Without modern chemistry, this planet could not sustain billions of people. A few million, maybe? Modern medicine would be impossible. I don't know, maybe there's a link there between not sustaining enough people and not modern medicine not being sustainable. Let me think. And it's like, and cleanliness and things like that we need to maintain. And sorry, that wouldn't be possible either, and it would be a pretty nasty way to go. So, and painting for protection wouldn't be possible for houses and for buildings and other things. We wouldn't be able to do that either. Or your car. And many of those coatings are necessary for, not only protection of that, but for other things that need to be outside, and for, we use them for power generation, things like that, a lot of these things. And the plastics make our world possible today. And there still would be other things that are produced by nature. And our own body produces things that harm us. And we either can deal with it or not. We call these responses allergies. Research is ongoing. Ways to treat it. Unfortunately, again, funding is not matching. So, I hope you learned something. I hope you found this interesting. Please comment below. There will be other episodes related to this, because how each one of these agents acts, how these classes behave towards your body, differs. And it is different for each individual. Some of us are more sensitive, some are less so. But all of them at a dose can cause harm. Water can kill you too much of it. Not just drowning, but if you were to drink too much of it. Everything and anything is dangerous at too high a dose. Yes, there is water poisoning. Again, and I'm not talking about waves or a hurricane, although that certainly does apply, and flooding in your basement. But water poisoning. So keep in mind that everything and anything, not just things with like 6 syllables. Even your favorite foods can. So do keep that in mind. Like and subscribe. Hit that bell icon. Select it to all. We'll see you again next time. Bye.